Hey there, deep dive buddy. Ready for a wild ride? We're diving into the worlds of quantum computers and AI, and let me tell you, this stuff is seriously mind-bending. We've got Scott Aaronson's insights to guide us, and trust me, this guy knows his stuff.
He's a leading voice in the field for sure.
So we're going to unpack what quantum computers really do. Beyond all the hype, can they crack the internet? Are they just good at chemistry? We'll tackle it all. And then there's the quantum measurement problem. Talk about a brain twister. It's like asking if reality is even real.
Yeah, it's a big one, for sure. Gets to the heart of what we know about the universe or think we know.
Exactly. And to top it off, we'll explore the crazy advancements in AI, like GPT-4. Could it outsmart us all one day? Oh, and get this, we'll even grapple with whether math is something we discover or just invent as we go along.
That's a deep one. I'm interested to see what you think.
It's going to be a wild ride, so buckle up. First up, quantum computers. They sound like something straight out of Star Trek, but what's the reality check?
Right. Everyone's heard the term, but the key is understanding that quantum computers aren't just faster versions of the computers we use now. It's a whole different ballgame.
Okay, so break it down for us. What makes them so different?
They use these things called qubits, which can be both a 0 and a 1 at the same time. Talk about a superpower.
Whoa. So like they're multitasking on a whole other level.
Exactly. That's what gives them the edge for certain tasks. For example, simulating molecules for drug discovery would be a game changer.
Instead of scientists spending years, even decades, trying to create new medicines, a quantum computer could speed up the process. No more waiting around for cures.
In theory, yeah. But developing these quantum algorithms, that's the tricky part.
Right, because there's that whole thing with Shor's algorithm and how it could potentially break the codes protecting our online world.
Exactly. Shor's algorithm was groundbreaking because it showed a quantum computer could factor massive numbers exponentially faster than any regular computer.
And that's a problem because our online security, banking, everything relies on those massive numbers being impossible to factor, right?
Exactly. However, finding these quantum speedups for other problems, it's been surprisingly difficult, like trying to find a needle in a haystack.
So why is it so hard to find these problems where quantum computers give us this huge advantage? It seems like they should be able to solve anything.
Well, think of it like a toolbox, right? You've got all these different tools, hammer, screwdriver, saw, each good for specific tasks. Quantum computers are like adding a laser cutter to that toolbox.
Okay, I like that.
It's super powerful, but only for certain jobs. Many problems are either too easy, too hard, or just not the right fit for what a quantum computer does well.
So Shor's algorithm, that's like finding the one specific thing that the laser cutter is perfect for.
Exactly. Factoring, that's where it shines. But those problems, they're few and far between.
Gotcha. Okay, that makes sense. Now let's dive into something that really makes my head spin. The quantum measurement problem.
Yes, the granddaddy of all quantum conundrums.
It's like the universe is playing dice with reality, and we've got no clue what the rules are. How did something like this even come up?
Well, it's been puzzling physicists for ages, this question. It goes like this. Imagine a coin spinning in the air, being both heads and tails at the same time.
Okay, I kind of see where you're going with this.
That's what a qubit can do, essentially. But the moment you try to catch it to measure which side it landed on, it suddenly becomes either heads or tails.
It's like the act of looking at it forces it to choose.
In a way, yes. And the big question is what makes it choose one state over the other.
It's enough to make you question everything you thought you knew about, well, reality.
Yeah.
Is it random, or is there some hidden force guiding these quantum events? So it's like the act of observing these quantum particles, these qubits, actually influences their behavior. It's like they know they're being watched.
It's a really strange thing, right? It's almost like the universe is shy. It doesn't want to reveal its secrets too easily.
That's one way to put it. But enough about the universe keeping its secrets close. Let's talk about something else that's changing rapidly. AI. Specifically, these incredible advancements we're seeing with things like ChatGPT. Seriously, have you played around with these things? It's wild.
I have. It's like almost like talking to another person.
Yeah.
It can be a bit unnerving sometimes.
Right. It's amazing and a little creepy all at the same time. Were you surprised by how quickly this technology has taken off? It seems like just yesterday we were making small talk with Siri and Alexa, and now we've got AI writing poetry and composing symphonies. What changed?
To be honest, I was a bit skeptical at first. I think, like a lot of people, I figured that to get to real AI, true artificial intelligence, we'd need a much deeper understanding of how the human brain works.
Not just feeding a bunch of data into a computer and hoping for the best.
Exactly. But then GPT-3 came along and, well, it kind of threw everyone for a loop.
It was a game changer for sure.
Totally. And the things it could do, generating human quality text, having actual conversations, even writing code, it was a real wake-up call.
So what was the secret sauce? How did we go from simple chatbots to AI that can write screenplays and compose music?
It's a few things, really. First, you've got this massive amount of data available now, especially text from the internet. And then couple that with huge leaps in computing power, and then add to that the refinements in how we design and train neural networks, and, well, it turns out scale matters more than we initially thought.
So feed a big enough neural network enough data, and it can start to pick up on patterns and make connections that humans might miss.
Essentially, yes. It can learn and adapt in ways that we're only just beginning to understand.
Okay, so does that mean we're on the fast track to super intelligent AI? Is there a limit to how smart these AI systems can get? Or can they just keep gobbling up data and getting smarter and smarter?
Well, that's the million-dollar question, isn't it? The honest answer is we don't know for sure. There are definitely limitations to the current approach. For one, the sheer amount of data and computing power we're talking about is immense, and it's not always clear that simply scaling up will be enough.
So there's a chance we hit a wall at some point.
It's possible, but the other thing we've learned is that we tend to underestimate AI's potential. What we think is a hard limit today might turn out to be not so hard after all. We've been surprised before.
So what you're saying is we might be underestimating AI. It could even surpass human capabilities in the future.
It's a real possibility. What if we discover a whole new technique, a breakthrough in AI design that we haven't even imagined yet?
So the idea of AI exceeding human intelligence in feels like, I don't know, math or music or even art. That's not as crazy as it sounds.
I don't think it's crazy at all. In fact, I think it's something we need to seriously consider because if it does happen, we need to be prepared.
Okay, so let's say, hypothetically, AI does become super intelligent. Are we talking about like a Terminator-style apocalypse here? Or is it going to be a bit more nuanced than that?
Well, I think the Terminator scenario makes for a good movie for sure, but the reality is likely to be much more complicated than that. The real worry with superintelligent AI isn't necessarily that it's going to become evil or anything, but that it might have goals that aren't aligned with our own.
Yes, aligned goals.
Okay.
So, like, what? Yeah, give me an example.
Okay, sure. Imagine you ask a superintelligent AI to, I don't know, design a new energy source, something that's totally clean and efficient. It comes up with something brilliant, revolutionary even, but in the process, it completely disregards the potential impact on, say, the environment or something.
Because those factors weren't part of its original programming.
Exactly. Or, even worse, what if we create AI so intelligent that it sees our attempts to control or limit it as a threat?
It's like trying to reason with a toddler who wants to stick a fork in an electrical socket. You just can't always get through.
It's a good analogy. And that's why the whole issue of AI safety is so important. It's not just about building more powerful AI. It's about making sure that as AI gets smarter, it remains beneficial to humanity.
So how do we do that? How do we make sure AI stays on our side, so to speak?
Well, it's a multifaceted challenge, that's for sure. We need to be thinking about ethical guidelines for AI development, putting in place robust regulatory frameworks, maybe even looking into technical solutions. Things like watermarking AI-generated content so we can always tell what's been created by a machine versus a human.
Right, to prevent things like misinformation and, I don't know, AI plagiarism, I guess.
Exactly. It's like we're essentially talking about teaching a child,
Right.
setting boundaries, making sure they understand the consequences of their actions. It's about raising AI with the right values.
Okay, that makes sense. But let's shift gears a bit here and talk about something a little more philosophical, but it gets to the heart of what we're talking about here. Mathematics. Is math something we've invented as humans, like a tool we've created to make sense of the world? Or is it something more fundamental, a universal language that exists independently of us? What are your thoughts on this?
Oh, that's a big one. That's a question that's been debated for centuries. Philosophers, mathematicians, they've gone back and forth on it forever.
And there were good arguments on both sides, right?
Definitely. On the one hand, you could say that math is just something we invented. Like, we look around, we see patterns in the world, and we create a system to describe those patterns. 3 apples, 3 trees, 3 planets. We invent the concept of 3, to represent that commonality.
So math is like a tool, a way to impose order on a chaotic universe, but not necessarily a reflection of any fundamental truth about that universe.
Exactly. It's like math is a map, right? A representation of the territory, but not the territory itself. It helps us to navigate, but it's not the actual terrain.
I like that analogy.
On the other hand, there's this whole other side to the coin.
Which is?
This idea that math is a universal language, something that exists whether we're here to discover it or not. Think about it. Math is incredibly effective at describing and predicting the physical world, the motion of the planets, the behavior of subatomic particles, even things like, the stock market to some extent. It's like we're tapping into some fundamental code underlying reality itself.
Okay. That's pretty profound when you think about it like that. It's like the universe is speaking to us in the language of math, and we're just starting to understand what it's saying.
It really is. And here's where it gets really interesting, at least in my opinion. This idea that math is a universal language, it kind of throws a wrench into the whole AI thing we were talking about.
Okay, how so?
Because think about it. If math is truly universal, then in theory, any sufficiently intelligent being, even an AI, should be able to discover it.
They wouldn't be limited by our human way of thinking about it.
Exactly. They could even potentially come up with entirely new mathematical concepts, things that we, with our limited human perspective, couldn't even begin to imagine.
Like, what if our human version of math is just scratching the surface of what's really out there?
It's a mind-blowing concept. But there's another perspective we haven't even touched on, one that challenges even the idea of a universal language of mathematics. Are you ready to go down that rabbit hole?
Oh, absolutely. Hit me with it. Oh, absolutely. Hit me with it.
Okay, so imagine this. We finally encounter an alien civilization, right? But not just any aliens. These beings, they evolved in a universe with totally different laws of physics than our own. Their reality operates on principles we can barely even comprehend.
Okay, now you're just messing with me.
Right.
Alien math. What's next?
I'm serious. Think about it. We're so used to thinking about the universe in terms of our own limited experience. But what if there are other universes out there, other realities where the very fabric of space-time, the forces that govern matter and energy, even the concept of cause and effect, are completely different from our own?
Okay, I'll bite. Let's say, hypothetically, these other universes, these other realities actually exist. What does that mean for our understanding of, well, everything?
Well, for one thing, it means that our understanding of mathematics, something we often consider to be like the universal language, might be far more limited than we realize.
You mean what we call math might be completely different in these other universes? Like their version of 2 + 2 doesn't equal 4.
It might not. Their reality might be based on completely different axioms, different ways of perceiving and organizing information.
So trying to talk to them about math would be like, I don't know, trying to explain color to someone who's been blind since birth. Their reality just doesn't include that information.
That's a great way to put it. They might have a system of knowledge that we could loosely translate as mathematics, but it could be based on patterns and relationships that we can't even begin to fathom. It would be like trying to explain the concept of up to a fish.
Wow, okay, that is a mind-blowing thought. So we're not just saying that our human understanding of math is limited, but that it might be fundamentally limited by the specific universe we happen to inhabit.
Exactly. It's a humbling thought, right? To think that for all of our scientific advancements, for all of our mathematical prowess, we're still just scratching the surface of what might be out there.
It really makes you appreciate the sheer scale of the unknown, doesn't it?
Absolutely. And, it also kind of makes you wonder, if we do create a super intelligent AI, something that can surpass human intelligence, would it be bound by those same limitations?
Oh, interesting point. So even a superintelligent AI might hit a wall, not because it's not smart enough, but because it's trapped in the same reality bubble as us.
Exactly. It could be blind to mathematical truths that exist in other universes, other realities. Truths that might make our current understanding of mathematics look like, I don't know, finger painting.
Wow. Okay, that's a lot to process. It's like just when you thought you had a handle on things, the universe throws another curveball your way.
That's the beauty of it, though, isn't it? The fact that there's always more to learn, always another mystery to unravel. And the best part is, with the power of AI, we might actually have a shot at unlocking some of these mysteries.
Yeah, maybe AI can help us see beyond our own limited perspective into those other realities, those other mathematical truths.
It's an exciting time to be alive, that's for sure. We're living in an age of incredible discovery and innovation.
It's a bit overwhelming too, though, wouldn't you say? I mean, we've gone from quantum computers to super intelligent AI to alien math in, like, what, an hour?
And we've only just scratched the surface.
Well, on that note, I think it's time to wrap up this deep dive. To our listeners, we hope you enjoyed this mind-bending exploration into the world of quantum computing, AI, and the nature of reality itself. If this conversation has sparked some new questions, some new ideas, that's fantastic. Keep those questions close, keep exploring, keep learning, and we'll catch you next time as we plunge headfirst into another uncharted territory of knowledge and imagination. Until then, happy diving.